of its level of difficulty in the mechanics of carrying it out, but rather because that's something that we're looking for. I've, in fact, promised you something just like that on the next test. Does everybody remember that? I promised you that I would give you one of those where you end up having to add the integral back over to the left-hand side. That's one of these. The only other ones where you do that really are the odd powers of the secant. And if I give you odd powers of the secant, you're going to be very upset with me. So I think it's going to be something like that. So you have two choices here. We already know what to do with this one. We know we're going to do integration by parts twice. We know we're going to end up repeating that integral over on the right-hand side and adding it back over to go with that. So we have two choices. We can let u be either e to the 2 theta or sine 3 theta. It doesn't matter which one you choose. Which one do you want? Sine, all right. So u is the sine of 3 theta, then dv is e to the 2 theta d theta. So du is 3 cosine 3 theta d theta, and v is 1/2 e to the 2 theta, and there we go. So u times v, I guess I should write the whole thing out. Knowing the form of this thing, we keep writing the left-hand side so that we remember to have this as an equation where we're going to add stuff back over to the left side. So u times v, 1/2 e to the 2 theta, sine 3 theta, u times v, minus the integral of v du, and that is a 3/2 integral v du e to the 2 theta cosine 3 theta d theta. Is that okay? All right, well, we have to do integration by parts again. Since we let u be the trig function the first time around, we have to repeat that. We're going to have to make u equal to cosine 3 theta this time around. That means that dv is now e to the 2 theta d theta. We've already integrated that, so we know it's 1/2 e to the 2 theta. The derivative here is minus 3 sine 3 theta. So, integral e to the 2 theta sine 3 theta d theta is 1/2 e to the 2 theta sine 3 theta minus 3/2 times the quantity. U times v is 1/2 e to the 2 theta cosine 3 theta minus the integral of v du is minus 3/2, so plus 3/2. The integral of e to the 2 theta sine 3 theta d theta, check and make sure I got all those minus signs and constants and all that correct. Look good? So as predicted, we've regenerated this original integrand. Let's see exactly what multiple of it we have over on the right-hand side. Well, 1/2 e to the 2 theta sine 3 theta minus 3/4 e to the 2 theta cosine 3 theta minus times plus is 9/4 integral e to the 2 theta sine 3 theta d theta. Now we're going to add that, well, I should say subtract it back over to the left-hand side. So what am I going to have over here when I combine that one with this one? Well, won't it be a minus 5/4?
No. I think you need to change sign.
Well, there's a minus 9.
Minus 9/4.
Oh, I get it. So when I add that back over here, it is going to be 9 and 4 indeed, 13/4. And that will equal, let's go ahead and just leave it that way. You don't need to factor out the 2 theta, the e to the 2 theta, unless that pleases you for some reason. Minus 3/4 e to the 2 theta cosine 3 theta And all we have to do now is multiply through by 4/13. Is that correct? We'll be done. E to the 2 theta sine 3 theta, d theta. And what will that give me? 2/13. Nice round even numbers. E to the 2 theta sine 3 theta. And then 3/13 negative. E to the 2 theta cosine 3 theta. And I'm done, right? I'm done, right? Well, you're gonna miss 1 point. Even
Plus
after
C.
all that work, isn't
Plus
it?
C.
Yeah, if you leave off that lousy plus C, I'm gonna take off 1.